Okay.
Prof, we are live.
All right.
Yeah.
All right. Fantastic. Okay. Thanks, Jide. Okay.
Just
So design science.
just as preface, because we don't know who's watching this and when they're watching.
Yeah.
So Prof. Hossana is giving a breakdown of methodology that we can use in information systems. So if you're watching this, you're probably one of our, myself or Prof. Hossana's master's or PhD students in information systems, and we've recommended to you to use a design science research methodology or approach. And Prof. Hossana is going to step through this model here, which is the design science research. And then after it, you can follow up with him is the author of he collected this piece, and you can ask him follow-up questions. Prof, over to you. Thank you, sir, for your time.
Right. No, thanks, Prof. Jide. This is fantastic. Okay, one of the beauties of design research is that it focuses on the product. Now, the way people look at product in information systems is very different. At a very high level, it could be a framework which just has words to say move from A to B. That's the kind of product. Another one is an algorithm like you have in computer science, which improves efficiency or improves efficiency in terms of time or even space. So design research is still an emergent field. So there are many strands of design research, but they kind of share certain things in common. So if you look at design research, you'll find many methods. So over the last couple of years, I've worked with many students on design research, and this method I have found to be most applicable. So I'm going to explain it from the left to the right, and then the one also below, but mainly the 6 blocks at the top here. So this paper is written by a gentleman called Matthew Malakay and Al Hevner. They're both from University of South Florida. Funny enough, they're both friends of mine. Yeah, I'm not trying to name drop, but Al Hevner is the world's #1 in design research. So he's the authority on this. So when you look at design research, at the left is problem identification. Let me see how I can annotate. Yes, let me annotate. So right here is problem identification. Information systems is all about problem identification. What is the problem? And taking your student Jide, who we just spoke to earlier on this morning, it was proofreading. Now, proofreading, for example, what problem does it solve in the bigger scheme of things? So you see, computer science focuses on efficiency, on improving things, on creating new products. Information systems is looking at what is the big problem. So when I step back and look at the bigger problem of proofreading from the context that she explained, she was looking at postgraduate supervision. That is the real problem. Now, in terms of postgraduate supervision, that is a big problem today. If you really look at it, particularly in South Africa, which is our context, tell me if an information systems or a computer science person who is South African, immediately they finish a PhD, what are the chances that they will become an academic? I mean, the money they get from academia is almost zero, which means, and also not just South Africa, in Africa. And for foreigners, because this is South African context, the moment they finish their PhDs, computer science, information systems, the money being thrown at them, not only in South Africa, but globally, just skyrockets. So retaining competency for postgraduate supervision is actually a problem. Now, this postgraduate supervision issue is a bigger problem, and it's been addressed by people like Mouton in Stellenbosch. He's one of the world leaders in postgraduate supervision. In South Africa, he's written quite a number of publications, and I'll share those some of those. She can actually Google them, postgraduate supervision, Mouton, and you can see that over the last couple of years, postgraduate supervision is a challenge. We have more postgraduate students, more African students want to study, but we don't have enough supervisors. So the bigger problem is postgraduate supervision. So if you frame your thesis, your proposal from a bigger problem like postgraduate supervision, there is a problem. We all know it. I feel it. At UNISA, I had at one point 20 PhD and master's students. And I had more about every day asking for supervision. So developing an artifact that would make my life so much easier, would make the life of so many other postgraduate supervisors so much easier. So if you frame your topic from a problem of that nature, immediately it becomes information systems, because the contribution, as everyone keeps talking about in information systems, is an artifact that solves a real problem. So that is a major contribution to knowledge. I hope that makes sense.
Yeah, it makes sense, Prof. And if I may interrupt you, because of whoever is watching this later on, that problem at supervision level, if I'm getting you right, it's broad, even though it is specific. And
Yes.
at a more cascaded lower level of granularity, one could say it's actually proofreading a student's proposal, because funding students is another problem in supervision. Many times the brightest students don't have the money. They write to me also, Prof, they said to me, I made a distinction, I made a first class, please find me some money to do master's or PhD. And if there's no money, institutional funding, so funding could be an aspect that someone is looking at. And that person could also go design science research to attempt to create a process or some form of artifacts to solve that problem.
Yes.
So would you still say, Prof, that the proofreading of a student proposal as a fractional problem of the first problem you described is still enough problem in this space for a PhD?
Oh yes, by all means. So it's a case of how you frame it and how you frame it in the wider scheme of things. It's a major problem. So proofreading is a sub problem of a bigger one. So a topic could be something like improving postgraduate supervision in information systems using machine learning. It's exactly what you're doing, but it's just framed differently. And the way it's explained is also different. Okay, so that is a bigger problem. Postgraduate supervision and sub-elements are proofreading, which is a problem which affects specific postgraduate supervisors. And then you come to the objectives of the solution. Now this is where you go into proofreading. What would a better artifact accomplish? This is the stage we're on now. So once you identify the problem, you bring it down to the smaller issue, not smaller, to the subdomain. And every domain, to say smaller is actually misleading, because every domain is just a putting together of many subdomains. Doesn't mean the bigger domain is more important than the subdomain. It just means that the subdomain is a way of chunking up things in order to make more sense.
Ontology, Prof, like some relation.
Thank you.
Yeah.
Fantastic. So in this case, the proofreading, the explanation of the proofreading starts here. You define what the solution is going to be, and then design and development is where you actually create your artifact. Okay, so now the objectives of the solution, if we just go back here, is you define proofreading, and this is how we're going to do it. Then we're going to design the artifact. Now, in designing of an artifact, there are basically 3 steps, which is typical information systems development, which is know your requirements, understand what people are doing, which you can do from a literature review, develop the artifact, evaluate it. It's as simple as that. So these 3 steps kind of go together. Know the requirements, and how do you gather the requirements, which is what you're doing already in NLP. Demonstrate it, you create the artifact, evaluate it. Now, evaluation is where you now send out surveys to postgraduate supervisors about, you can even do an interpretive where only 10 supervisors respond and say, we like this, we don't like this, improve this. And then in the meantime, you're publishing.
Sorry to interrupt you. If I may please take you back to evaluation. So is this where you say something like you are using a quantitative method to evaluate, a qualitative method to evaluate? And in the quantitative one, you can have a higher number of surveys and look at statistical correlations. When a qualitative one, you can have a focus group of experts that you interview and they give you something you transcribe, then you then do something further on it, maybe a quantitative interpretation or a narrative inference on it.
Perfect, 100%. Evaluation is open. It could even be observations. You don't even have to collect data. You could just observe how people use it, like you have in HCI. You observe, you evaluate, you can use heuristics, you can measure how work. So evaluation is really open. And that's the beauty of design science, is that it allows for that openness. So your computer science, effectively, your model would fall within this space here. So she creates her entire artifact, and at the end of the day, we evaluate it using whatever method is most suitable. Of course, the advantage of quantitative is that you get many publications. You just slice one direction, slice another one. You can even apply data analytics, and then you have another paper. But that's something for another day as you get towards the end.
And Prof,
and then
the demonstration part is the experiment that produces results from the, let's just say hypothetically, the design and development is design development of a mobile app. For example, let's say the problem is a problem in healthcare, and the solution that we are trying to picture is a mobile app that could solve that problem. Maybe communication in a multidisciplinary healthcare team. So the demonstration now will now be testing of that app. Am I right, Prof?
Yes, that's correct, 100%.
The evaluation will then be the feedback from the testers on how effective this app is.
Correct.
Fantastic, Prof. Thank you.
As simple as that. So, and then you communicate the results. And all that, so you can see computer science falls within design research, not falls within, but design research provides an umbrella within information systems for computer science research. And the beauty is that the focus of information systems over the last couple of years, we've spoken this with Prof. Jide, is it has been moving towards products. The reality is many of these processes have been automated. There's an app for almost everything that you can think about. So to continue hammering at in fact, one of my PhD students was doing an analysis of the 4IR technologies, and he found that information systems' most popular theory, and well, the only theory, which is technology adoption, is no longer relevant in the 4IR. Because technology has there's so many products. So what's the big deal? Anyway, I'm digressing. So this is the bigger picture of design science, okay? And then what this particular paper does, it breaks it down into 4 major steps. The problem-centered approach, you're focusing on a problem, you're delivering a solution, okay? You're evaluating the solution, and then you are refining it. So what design science does, and particularly for this student, is we could work on problematizing. Problematizing in the sense of what's the bigger problem we are fixing at the beginning. Those are just 1 or 2 pages. And if you Google postgraduate supervision, very important to show references which are fairly old and new references. Now, what Mouton has done is he has shown over the years how postgraduate supervision is increasing, but supervisors are decreasing, and yet output is still expected the same. So showing a graph like that in your showing with 2020 references and also 2015 references shows that it's not only a current problem, it is an existing and increasing problem. So what I will do is I will send you only 2 papers, just not overwhelm you. This paper and another paper which just talks about design science and what it focuses on. And you could reshape your slides again. And then we could meet again on, say, Monday or Sunday, whichever. Well, these days you don't know what day it is. And then just rework through your proposal. We'll brainstorm it after Jide has worked with you, and then we could rediscuss it. But I think it's a very powerful thesis that you're doing, which could result in IP, in my opinion.
Yeah, a great IP. Prof, first, thank you for your time. There are a few things that I would like us to add to this video so that you and I actually thought about this, Prof. I thought my regular feedbacks that I give to my students at postgraduate level, because with my undergraduate students, I have YouTube videos, I have a channel there. And for postgraduate students, most times if I sit a repetition, I just say, speak to the other student and tell him to tell you what to do. Do it first before you get to me, so that I don't end up spending very crucial time repeating myself and again, over and again, over and again. So Prof, if we could add to this video before we finish this meeting,
Okay.
an hypothetical structure that assumes that a research work in information system is based on the producing a product. And we can then say, if you are going to create a product as part of this research, and you're using DSR, even if you're not creating a product, but if you're using DSR, this is how hypothetically your section 3, or you're popularly known as section 3, but your research methodology should look like in your proposal, and of course in your final thesis, which of course, depending on what you're working on, you can flesh it out left, right, center, but like the skeleton of it. So, which of course will contain some aspects here. And that leads me to the next question, Prof.
Okay.
The problem identification and objectives, even though they're part of the DSR model, are they not supposed to appear elsewhere in the proposal, whereas one could still talk about them in the methodology session to say, this is the DSR image, adapted from, reference the source, and now say, this box 1, 2, 3 has been described in previous chapter, then this box 5, 6, 7 is now what we discuss here. In that case, one could extract design and development, talk about it in computer science terms, then extract demonstration, talk about it in whatever terms, then extract evaluation, and talk about it in pure social science terms, because evaluation always takes us back to social science and statistics actually, and things like that. So what would you say, Prof? What's your opinion about that?
I agree entirely. If you even look at those 6 blocks, these are chapters in themselves. Chapter 1, problem identification. Chapter 2, objectives. Chapter 3, methodology. Chapter 4, results and discussion. Chapter 5, conclusions. Chapter 6, the papers. So DSR is very, very flexible. But because I come from an information systems background, we love philosophy a lot. So we kind of drop in philosophy somewhere in between there. But that's because of, can I say, disciplinary bias. But DSR allows for many things. And I've had PhD students graduating in design science research without a challenge at all. And so,
a question that comes to mind is, when we are completing ethics clearance in information systems, we always have this column that is asking us, what is your research methodology? And there are only 3 options in that box. Quantitative, qualitative, and mixed. Would it be right to say this is mixed, because the DSA contains artifact development, which is like computational techniques when you're working in the space of developing like 4IR artifacts, and evaluation in DSA then translates to say quantitative things. Would it be okay to say that's mixed and then try to explain it as DSR?
It's none of the above. In fact, DSR comes from engineering, believe it or not. So we've got to change that form. There's no question about that. And I think what we need to do is immediately start the process and just create your own box and tick it and say design research. So it doesn't fall in those 2. And that's an argument which has already been dealt with globally. The DSR is just another lens, which is not qualitative or quantitative, nor is it mixed. Although it takes within itself all those other methods as you want, as we spoke about earlier, as part of evaluation. And or for example, what I'll do, I'll send another paper of mine, which another student has just finished publishing. It's coming out in December in DESRIST. That's the world's leading design science research platform. So that's my boss, also called my wife. So let me just answer that. So so I'll also just add a paper just to show you how design science research can be done. You see that he applied interpretivism in order to identify the requirements. And then later he used quantitative method in order to evaluate and interpret the results of his artifact. So you can see it's not mixed, it's a method of its own. He didn't have to do that, but just for the sake of rigor, we did that. So it's very broad. So we need to have that conversation.
And Prof, in case you might not notice, you have actually helped the student, not in terms of just the methodology, but this topic is a paradox because this topic is how to do research, and that research itself is an automation of how to do research. Because the proofreader,
Fantastic.
and now that you've broken this down, it means that when the student is writing the algorithms, they will make sure the algorithm also considers these things in finding which part of the proposal is right and which part of the proposal is wrong. So in terms of structuring their proposal, that's the first help you've provided. The second help you've provided is the knowledge of that AI. You've helped the student to be able to write rules that can see if the student is using design science, these things should be present and these things should not be present, and which is highly appreciated.
Anytime, anytime. So I think going forward, I'm going to send you the 2 papers. I don't know whether you want to schedule a meeting already for Monday or Sunday or
yes, Prof.
Tuesday.
So the plan is I want to send this video to the candidates at hand and also share it on, I'll just put it on my channel, YouTube channel. It's not a public channel, it's only people that are invited to use it. And if you have any of your students that is using design science, you want them to come see it, this is of course your property. You let me know, then I'll share the link with you, and that can save us some time of re-explaining this whole thing. And the only thing I think we should have now, which you and I can of course always work on later, is a breakdown of the methodology session for projects like that. So we can just work on that and then attach it to as a note on this video to say the structure of your methodology. And I think you have some, I already have some where we say, this is the structure of your proposal. Introduction, problem statement, aims, objectives, contribution to knowledge, all of those things. Just that we want to say, if your supervisor already says what we are going to use is DSR, then this is how you structure that session. That way our colleagues in information systems can be comfortable and our colleagues also in computer science can see where our contributions lie.
Okay. No, fantastic. No, I like the way you think. You think like a computer scientist. You know how to break things down, making them more efficient.
Bro, don't believe me, I'm a computer scientist. And I used to think it's fashionable until I meet information systems people that are more philosophical than me. Then I think computer science is too technical and I have to think more philosophical. So I don't think it's an either or. I think when I meet positive people like you that are willing to educate me as a computer scientist on philosophy, then I listen and I learn. And also when information systems philosophers meet computer scientists like us and we want to show them something that is very fun that we've created, and they have listening ears, they're also mostly blown away. They're like, oh, this is very cool. So it is a symbiotic relationship, Prof. Both of us are learning every time.
Fantastic. So I'm going to share this with you immediately, just two design science papers and then one paper which my student has just finished. And then we could always have another conversation. I recommend the student works on this thing until by Monday we meet again and then just run through her presentation and how she has understood it. How is that?
Stop the recording now, Prof, because we don't have anything to add to this so-called video module. Then you and I can go back to other academic conversations.